Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. To convert p-chloronitrobenzene to p-chlorophenol, we need to replace the nitro group, NO2, with a hydroxyl group, or while retaining the chloro substituent. Moving on to the next step. Reduce the nitro group to an amine using FeHCl, a classical nitro reduction. This converts p-chloronitrobenzene into p-chloroaniline. Moving on to the next step. Treat with NaOH to neutralize and free the amine. Since FeHCl gives the ammonium salt, NaOH liberates the free amine, p-chloroaniline. And for the final step, diazotization, treat p-chloroaniline with NaO2 and H2SO4 or HCl at 0.5 degrees C to form the diazonium salt, p-chlorobenzenediazonium hydrogen sulfate. Hydrolyze the diazonium salt by warming with water, H2O, heat. The diazonium group, N2+, is replaced by O, yielding p-chlorophenol. Why other options fail? Option A. H3PO2 is a reducing agent used to replace N2+ with H deamination, which would give chlorobenzene, not p-chlorophenol. Option C. Ethanol as the last reagent would reduce the diazonium salt to give the arene, chlorobenzene, not p-chlorophenol. Option D. NaOH heat on p-chloronitrobenzene could cause nucleophilic aromatic substitution of Cl with O only if conditions are extreme and the ring is activated, but this is not a reliable or standard synthesis route and would not selectively give p-chlorophenol cleanly from p-chloronitrobenzene. The correct sequence is reduce number to 2NH2, Fe, HCl, liberate free amine, NaOH, diazotize, NaO2, H2SO4, then hydrolyze diazonium with H2O heat to get O. Therefore, the correct answer is B. Therefore, the correct answer is option B.